Hi, and welcome to our first video. This video is going to cover Chapter 1, Sections 1 and 2. Down here it's telling you that the problems that you will see are from Edition 4 of the book. The Edition 3 problems are almost all the same, and when they're not, I will put that in parentheses. Our introduction here is not just for this chapter and not just for the semester, but really for chemistry in general. The definition of chemistry is that it's a connection between our micro and macro worlds. So the pictures down here show us graphite on the microscopic level and graphite on the macroscopic level. So it's a comparison between what we can see and what we can't see. And the connection is really an explanation of what's going on. So graphite is made up of carbon. So each of these little balls represents a carbon, and they're bonded together, and that's what the white sticks represent, in sheets. And so this represents 4 different sheets. And then the sheets are attracted to each other. That's what the black lines are representing. But the attractions are weaker than the bonds. And so when we use a pencil and we push down with that lead, we're pushing off the sheets of graphite. We're breaking those attractions. So chemistry explains why we can write with a graphite pencil based on the microscopic properties. And so this is a really big theme throughout all of chemistry that we will use a lot this semester, and then more if you continue on throughout Chem 1B and organic chemistry. Our first section is really just a bunch of definitions. So we have probably the 2 words we'll use the most, atoms and molecules. Atoms are the smallest building block of matter that we have, and they are labeled as submicroscopic, which means even smaller than microscopic. They're very, very tiny. When we take those atoms and we bond them together, we make molecules. A molecule is made up of at least 2 atoms, and they can be the same type or a different type. So there's a couple molecules on the slide here. Water, H2O, it's represented with 2 hydrogen atoms and 1 oxygen atom, and they're squished together because that's representing that they're chemically bonded to each other. Another one down here, and I like this one because it shows it in different formats. CH4 is methane. It's represented here as a Lewis structure, which we'll learn how to draw in a later chapter. Over here, this is called a ball and stick model because it looks like balls and sticks. But we have the carbon in the center, and the 4 hydrogens are connected to it. The stick part is representing the chemical bond. And then this is called a space-filling model. It's a little bit more difficult to see, especially when the molecules get larger. Things can kind of get hidden. But it's actually the most accurate representation of what the molecules look like because everything is very close together. This is the one we will draw the most, and this is probably the one that we look at the most, even though this one's the most accurate. We talked about this a little bit in the introduction slide, but it's also something we'll talk about further in this chapter during lecture. So chemical and physical properties. And then the last definition here is something we've already discussed on the previous slide. A hypothesis can turn into a theory. And again, we can continue testing that, especially as technology improves. And our observation, if we make enough of them, can turn into a law. Now, the one thing I like about this flowchart is that it does have all these little loops built into it because we do continue to test things and revise things. Takes us to our first practice question. So this is number 34. It says classify each statement as an observation, a law, or a theory. So the first one says chlorine is a highly reactive gas. Well, that's not telling us why anything is happening, so we can cross off theory. So then we have to decide between observation or law. And this is really just talking about chlorine. It's not combining a bunch of observations into one thing, so we can label this as an observation. The second one says, if elements are listed in order of increasing mass of their atoms, their chemical reactivity follow a repeating pattern. Now this isn't telling us why that happens, so again, we can cross off theory. So now we have observation or law. Now there's more than one element involved. we're involving their masses, we're involving their reactivity. So this would be a bunch of observations combined together. So we can safely say that this is a law. And it actually is. It's called the periodic law. It's something we'll talk about in a future chapter. The next one says neon is an inert gas. Inert means non-reactive. Now this is actually just like the first statement. Because it's not explaining why, we can cross off theory. And because it's really just involving neon, we can label it as an observation. And then our last one says, the reactivity of elements depends on the arrangement of their electrons. Now this one is involving a why. It's not just telling us that the elements are reactive, it's telling us that they're reactive because of their arrangement of their electrons. So observation is out and law is out, and we can label it as a theory because it's telling us why something is happening. Our last topic in this video is the law of conservation of mass. So the law of conservation of mass says that in a chemical reaction, matter is neither created nor destroyed. Now this law is something that we actually utilize a lot, especially when we're doing math. It's the way that the math was developed. Antoine Lavoisier over here is the one that developed the law. And down here is an example of it. So on the left side of the arrow, we have butane and oxygen. So those represent our reactants. The arrow is telling us that it's going to turn into our products, which are on the right, water and carbon dioxide. And it's giving us our amounts. 44 grams of butane, 160 grams of oxygen, or 204 grams altogether. If we put those together, it will make 72 grams of water and 132 grams of carbon dioxide. And that, again, will make 204 grams of products. So the law of conservation of mass says that these two numbers have to be equal to each other because we can't magically make anything extra. We can't magically make anything disappear. So this is an important concept for us that we'll utilize in the math that we do throughout the semester. All right, that's the end of our first video. Thank you.